Euclidean geometry. This is part 6. We are going to discuss the similarity theorem. Okay, watch very carefully. We are now looking at a very beautiful theorem, very important theorem, similarity theorem. The corresponding sides of two equiangular triangles, equal angles. Look at the triangle here. Angle A equal to angle D, angle B equal to angle E, angle C equal to angle F. So they are called equiangular, not equal triangles. One is big, the other one is small. The sides are different, but the angles are, corresponding angles are equal. So equiangular triangles are in the same proportion. What's the meaning? AB over DE will be equal to AC over DF or equal to BC over E. Same proportion, and therefore we call them similar triangles. Okay, so equiangular triangles are similar. That is the theorem. Now we are going to prove it. Given angle A equal to D, angle B equal to E, and angle C equal to F. We always write those given informations. Required to prove, that's our second step, AB over DE equal to AC over DF equal to BC over F. Now look at the construction. On AB, on the line AB, we mark a point G such that A to G, AG is equal to DE. Again, on the side AC, we mark another point H so that AH, the length of A to H, will be equal to DF. Then we join GH. That is our construction. Now we come to the proof. Now let us look at the diagram again. We have the two small triangles here, AGH and DEF, where AG is equal to DE because we marked point G. Again, angle A is equal to angle D, already given. AH is equal to DF, that is also our construction. So what we understand? Two angles, two sides, and one angle of this triangle is equal to two sides and another angle of this other triangle. So they are congruent. We say triangle AGH is congruent to triangle DEF. Reason side, angle, side. Okay. Now when they are equal, these two small triangles are equal. What we have seen, okay, look at this angle G1. G1 must be equal to angle E. But we know that angle B and angle E are also equal. It's given. Therefore, G1 is equal to B. Okay. Now, what type of angles are they? They are corresponding. If you consider these lines BC and GH, G1 and B are corresponding angles. So what we understand, GH is parallel to BC. GH is parallel to BC. Now we make use of the proportional theorem. Proportionality theorem, the parallel line, a line drawn parallel to one side. Okay. So the proportion, the ratios, AB from A to B over AG will be equal to AC over AH. Okay, making use of proportionality theorem. Therefore, what is AG actually? Because of our concept, AG is the same as D. So in the place of AG, we will write DE. In the place of AH, we can write DF. Okay, so we get AB over DE is equal to AC over DF. Now, in the same way, if you draw a dotted line construct on BC, okay, you can imagine another line. Similarly, we can prove. We will prove that AB over DE will be equal to BC over EF. We just write similarly. So when we combine all of them, AB over DE is equal to AC over DF equal to BC over EF. That is the proof of the equiangular triangles and similarity theorem. Okay, learn it very well. Write down the proof 3 or 4 times. Let us look at few questions. The writers on proportionality theorem and similarity theorem. In triangle PST, TS perpendicular to PS, it's clearly shown. RQ perpendicular to PT, okay, all these are available here. Prove that triangle PRQ is similar to triangle PST. Okay, so we are going to make use of the similar triangle properties. Okay, we locate the triangles PRQ and PST. Both are right angled triangles. You can see 90 degree there. So the first angle, let us concentrate on angle P. Angle P is a common angle for both triangles. So we write angle P equal to P common. Next, in this small triangle, angle R1 is 90 degree because it is perpendicular. Okay, it's given in the question. RQ is perpendicular to PT, and in the big triangle S1 plus S2, okay, that is angle S, but it is S1 plus S2 is also 90 degrees given. The third angle is automatically equal because the sum of the angles of triangle. Therefore, the three angles of the small triangle PRQ are equal to three angles of the triangle PST. Therefore, equiangular. That is our conclusion. When they are equiangular, the triangles are similar. Okay, that is how we prove. Again, we continue with the same diagram. Question B. Prove that RQ is to PQ is equal to ST is to PT. So already we have answered number A. We got the triangles are similar. Now the question is RQ is to PQ or RQ over PQ. That's the meaning. So what we have to do is, we know that when the triangles are similar, the corresponding sides are in proportion. But we don't need to write the whole thing there. RQ is to PQ and ST is to PT. So we go to the triangle. RQ, if you choose RQ, look at this. RQ over PQ, look at that. PQ here, okay, we can draw like this. This is PQ. Then in the second triangle, you look at that one. It should be second and third letter, ST and PT. So we can write that ratio there. Okay, what we write? So this is the whole thing, but we want actually only RQ over PQ is equal to ST over PT. Simple as that. Now we can write what is our question? RQ is to PQ. So we write in the format. That is our answer for B. Now what about number C? It is not PR times PT. PR times PT. Okay, again let us go. We have PQ, PS, PR, PT like that. So PR, let us take PR over, we can write PS, okay, equal to, what is the next one we want? PT and PS, PQ. Okay, here we have PQ over PT. When we read the question, we find all those easy techniques. So we can write PR over PS is equal to PQ over PT, cross multiply PR times PT, okay, equal to PQ times PS. That is a simple method of answering. So you concentrate on the letters of the three letters of the triangle, okay. Converse of similarity theorem. In the similarity theorem, we were talking about equiangular triangles, and then the sides are in proportion. Now here the sides are proportional. If the corresponding sides of two triangles are in the same proportion, the two triangles are equiangular and therefore similar. So opposite way. Okay. So we need not learn the proof of this theorem, but we must know it. Okay, we have one question from the similarity theorem again. In triangle DGH, all the informations are on the diagram. Prove that DEF is similar to DHG. Okay, that's what we are going to answer. DEF similar. So we have no idea about the angles here, but we are going to use these proportions. Okay, so how do you start? We can say, if you take DE, look at that one, DE over, then what is the letter DH, like that. We take all the proportions, DE over DH. Well, how much is there on the diagram? DE from D to E is 4. DH from D to H is 6 plus 2, 8. So we get 4 over 8 equal to half. Okay. Then we can go for the other sides. EF, look at this one. EF over what? It should be HG. EF over HG. Go to the diagram. Okay. Then you calculate. What is that? EF, how much? EF is 5. Okay. And HG is 10. We get again half. Okay, like that. The third side, DF, okay, go there, D to F, then here it should be D to G. DF over DG, okay, is 6 over 12. That is equal to half again. So all these ratios are equal to half. Therefore, they are all equal. They are all equal. What is the meaning? The sides are in proportion. Therefore, the triangles are similar. Simple. So master all these techniques. So that is the end of part 6 of Euclidean geometry. You must realize that we cannot practice so many questions, but I have given you the theorems and the proof and few good questions and the method how to tackle these questions. Okay, watch these videos again and again and prepare very well for the exams. Good luck.